Hello, data professionals, beginners and pros alike. You're welcome to this channel where we make data make sense. In today's video, I will walk you through the 9 essential steps in the data analysis or data science project process. To give you the exact roadmap that professionals use to go from messy data to powerful insights. Whether you are just starting out or brushing up your skills, this guide will help you build confidence and think like a real analyst or scientist. So step by step. Stick around to the end. I've got a whole lot of tips to help you avoid the biggest mistakes beginners make. Don't forget to like, subscribe, and hit the notification bell, so you don't miss out on more practical data tips and analysis tips also. So stay with us. Let's get started. The reason why I'm doing this video is because I don't want you to go through the same struggles I went through in my early years as a data analyst. So I had struggles having a correct framework of what steps to take whenever I have a data to work with. I know that's not one of the things that many tutors teach us. They want to teach us how to analyze with softwares, with R, with Power BI, with Python, with Stata, and what have you. But then there is a framework that is necessary, not just to put in the codes in your head and how to go about a software, how to maneuver your way through a software. Why that's part of it, you need to have a framework. You need to understand each steps. So for this reason, I have summarized the data analysis or data science projects, any project, into 9 essential steps that are necessary, that you cannot do without. So here you have the workflow, summarizing the 9 steps, the list of the 9 steps, starting from defining the objective to documentation and reproducibility. So let's go into them one after the other. Stay with me. So the first step in any data analysis work, any data project, is to define the objective. Why do you need data in the first place? What do you want to do with the data? It means in essence that you want to understand the problem, what you really want to use the data for. What do you want to achieve with the data? This is where you plan on gaining clarity. So it sets the course for you. When I lay my hands on this data set, this is what I want to do with it. These are the inferences I want to make. These are the questions I want to ask the data. These are the things I want the data to inform me of. So that's the first step, defining the objective. So the next step is data collection. You see, for any data work, any inference you're going to come up with, any action that you want to take after analysis, after any project you do with the data, they are only as important and as qualitative or as quality as your data is. So if you have a wrong data set, if you will still have something to work with, definitely, and you would have inferences, but then they would be misleading. So in essence, your data collection process must be properly monitored. You must ensure that it's relevant data, accurate, and ethical. So you must keep track of all these things to ensure that whenever you put in the yard, you put in the work to analyze your data, every inference that you come out with are telling you the right things, because your data is quality and relevant, right? So we move to the next point, data cleaning or preparation. Here you handle missing values. Like from the word cleaning, it means that there are impurities in your data. So to say, there are debts in your data, like things you don't want in your data or that are not supposed to be there. If your data is not cleaned, the quality of your work will be grossly and greatly affected. So that's why you have to do a whole lot of work in the data cleaning. This is one of the places where you must be most careful in any data project you undertake. So you handle missing values, whether by imputation, deletion, or flagging. There are different methods to work on missing values. So you want to do that there. You want to check for outliers, whether there needs to be valued. There are values that needs to be treated as outliers and then dealt with. You remove duplicates and errors. You standardize formats. This is where we scale or normalize variables, transform them as may be needed, as may be required. So the next step after data cleaning is what we call exploratory data analysis. Exploratory data analysis or data exploration. So here we usually deal with descriptive analysis and visualization. Descriptive analysis and visualizations. Here we use usually the summary statistics, such as the measures of central tendency and dispersion, the mean, median, standard deviation, variance, mode, IQR, and all the likes. So we do data visualization here using all those graphical illustration methods, histograms, box plots, QQ plots, normal quartile plots, scatter plots, time plots, bar charts, column charts, and what have you. What this helps you to do is to identify patterns, trends, anomalies in your data sets. And actually, many of them help you to check assumptions, whether they fit in for the kind of modeling that you want to do. So for example, now you could easily check using a normal quartile plot or box plots to check for, okay, you use box plots to check for outliers, you use normal quartile plots to check the shape of the distribution. For example, if you're running a regression or time series related analysis on your data, you want to check, one of the assumptions is that the variables are normally distributed. So you want to check using a box plot, you want to check using a normal quantile plot as whether your data is normally distributed. So this is where you check assumptions for your statistical modeling. After that, you go, having confirmed that your data is ready for modeling, your data is ready for analysis, as whichever case may be, you go to the data modeling per se. Okay, before I go to that, I want to tell you that the two former steps are related. That is the data cleaning or preprocessing and the exploratory data analysis. Most of the times they are intertwined. A whole lot of analysts, like if you're a Power BI analyst, you are not really doing a modeling such as statistical modeling and the likes. You do visualizations, you make inferences out of the data. So you might really be stopping your own data analysis work at the fourth point. But if you're a data scientist, here you choose method, statistical tests to use, machine learning models to build, regression, clustering, etc. Like that. You build your models, you do testing and training to validate models, and then you build your models. You train your models based on the nature of the data and the objective. Don't forget that word, objective. That's the key thing there. And then you want to evaluate the performances of such models, their predictive performances, the accuracy in the classification, and anything of the model. Okay, so inferences and interpretation of results comes next. Here you want to draw conclusions, make your inferences, interpret what you are getting from the data from your analysis. You want to assess the significance and the statistical significance of the results that you got from your modeling, from your analysis. So that's that. Communication and reporting. You must be a very good storyteller. That's one of the most important skills that a data analyst, a data scientist must develop. Ability to communicate. Not everybody understands the numbers, the reports, the results that you put on ground. But you must be a very good storyteller, or you must develop that skill enough to ensure that the detail level can be understood, can be absorbed by both technical and non-technical stakeholders. Both people who are not data oriented can also benefit from. Most of the times you find yourself working with people who are not data oriented. They just want to hear a story that is easily absorbable. So you can make recommendations from here based on the insight and evidence of what you have. You must be a good storyteller to convince people that this is what the data is saying and these are the steps that needs to be taken. So the decision making and action is left for the data users. You have done your work. If you are no longer involved, maybe your own work as a data analyst or data scientist stops at the 7th step. So you leave this to them. You have already turned the data into actionable insights for them. So theirs is to generate actions and ensure that the data works for them based on your recommendation. And if, for example, maybe you're a researcher and you still have to do this step yourself, then you go ahead with it. So the last one is that you document your codes for reproducibility. So many times you would have to walk through the same process that you have worked on a different data. So you can have similar data and you can have similar steps you want to take concerning the data, similar problems you want to solve. So it's wise for you to record your codes, to record your steps and your codes, so that it can easily be replicated rather, whether by you or any other person. So for example, if you are using Stata to analyze, you use your do files, ensure to save your codes there. If you are using R or Python, you use a script there to save your code so that you can easily come back to it and make a little tweak anytime you need to again, so that you won't have to start over. So here, this is the end of this tutorial. I believe that you must have learned a lot from it, especially if you are a beginner. So stay tuned to this channel. Please, if you have not subscribed, ensure that you subscribe, like and share. That's the help that you can do for us and for other analysts that will be stumbling upon this video. So we'll meet again. Don't forget to check back again as we drop contents that are useful for you.